Hi, Math 3 students. Welcome back. So this is a video for graphing trig functions. So there are 3 quizzes you need to do, and this is one of them. So let's proceed, okay? So question 1. So below are 4 different graphs, each one a different color. So which graph is which? So we have only learned 2 trigonometric functions at the moment. We have learned sine and we have learned cosine. Now, tangent will come a little bit later. But as you can see, tangent doesn't look anything like any of those 4 colored graphs. So here, sine, right? Sine always starts from, well, not always, but we know that the original sine graph should start at 0, right? The original sine graph should start at 0. So here. So let's talk about the first graph is y equals to sine x, okay? Y equals to sine x. Now, let's draw a typical sine x graph. Now, first we need the period. The period is the duration or the degree that it takes, or radian that it takes to finish one complete cycle, right? Now, so we have the period, then we need to take half of it because it's always, we need to know when is the halfway point. So this is the half. Now, for sine, it will start at 0, and then it goes up to the highest point where the amplitude is, and it comes down, cuts the middle. Do you see now why I need to set the half in the middle? Then it comes down, but then it goes straight down to the amplitude, and then go back up to my first point that I drew, the period. So see how it finished one complete cycle. Now the cosine, all right, let's draw the graph. So we need a period, and then we need to halve it. But what is interesting about cosine is that it doesn't start from 0. It starts at the amplitude, right, the highest point. Now, if it starts at the amplitude, it's going to end, well, it's going to go down to the lowest point in the middle, right? And then it's going to end back up, right, the highest point at the period. So it's going to go like this. Okay, so as you can see, the sine graph would correspond to the red graph, right? And the cosine graph would correspond to the blue. Okay, question number 2. We're supposed to sketch the graph. So here using this technology, which is pretty cool. So now, sine x, right? Sine x. Now we know that sine x starts at the 0. And if you look at the x-axis, it's actually in degrees, right? Every division, every box is 45 degrees, 45 degrees, 45 degrees. So, so we need to choose. We need to choose. Okay, so we're gonna pick this particular feature. The reason why we picked this particular feature is that the other one, the one on the left, it picks the highest and the lowest, whereas this feature, the one that I just circled, you can actually make it so that it starts in the middle. So, so I'm going to show you what I mean by start from the middle. So if I pick this one, and then if I put it here in the middle, not in the middle, in the 0, and then, yep, see how it works? Now I know the amplitude is 1, but the period is 360 degrees. So, yep, there you go. So once I set it, so this is how it goes from 0, then it goes to highest point, which is amplitude 1 at 90 degrees, and goes back to 0 at 180 degrees. Then it goes down to negative 1 at 270 degrees, then go back to 0 at 360. Okay? All right. Now, if you look at question 3, cosine. Cosine, we need to pick the other one, the top and the bottom, the highest points, because we know it's going to start at 1. So let's pick the point. The highest point starts at 1. You see how I can drag down? I can drag it down. Nope. Okay, so see how this looks like? And set it. So the highest point, which is at 1, right? And then it becomes 0 at 90 degrees. Then it goes to -1 at 180 degrees, back to 0 at 270 degrees, and then goes up to the highest point, the amplitude at 1 at 360 degrees. Okay. Okay, so this question, you need to look at the graph and then decide where the amplitude is, the midline, and the period of the function. Now, the way I look at this question is always easier to actually find the midline, because what do? We use the midline to draw graphs typically, right? To begin with, we use the midline. So let's try to find the midline here. So the midline is right there, and so because it's half the distance up and half the distance down, right? And here it's y equals to -3. So we put the -3 right here at the midline. And then we look at the amplitude. Amplitude is what's the peak, the highest point. Here the highest point, the distance from there to the midline is about 3. And then if you look down below, it's about 3 units down also. So amplitude, right? So it's about 3 units, and we put it right here. Then we need to look at period. Period is the degrees or the radians. So in this case, if you look at the x-axis, it's in radians. It's not in degrees, but it is in radian. So we need to look at what the period, which is the amount of radians it takes to finish one complete cycle. So it's from there, look at the midline, from the original point there, starting all the way to the point 5. So here the period is 5. So we put the 5 here. Okay. Right, so to do this question, we're supposed to sketch a graph that of the function fx equals to 4 sine x plus 3. So first thing first is that we need to look at this number, which is the midline. Midline equals to y equals to 3. Then we put a dotted line across, right? Okay, because it's half above, half below. And then we need to look at this number 4, and that number 4 tells us the amplitude, how high it goes. So it goes up as high as 7 and it goes down as low as -1, right? Because it starts at 3. Midline is 3. So the period, now this is a bit tricky. Period, we usually take 360 degrees divided by this particular number in front of the x there. But here the number is 1, since there's no number, it's 1. Then we divide 360 degrees by 1, which means that in 360 degrees, it will finish one cycle. But if you look at the axis here, the x-axis is not in degrees, it's in radians. So 360 degrees, we know it's 2 pi, so 2 pi over 1. So we set it at 2 pi, and then we have it, all right? So we know it's going to start at 0, because this is sine graph, right? It's a sine graph, so it starts at the origin, which is at the midline 3, and then let's make a cross there, and then a cross at pi, a cross at 2 pi. And then highest will be at 7, right, in the middle of the first part there, and then the lowest is at -1, the second part there, and we just draw it like that. Then the same thing, right? So hopefully this explains it. I'm going to show you how I actually do graph it. So let's exit. Now I'm going to pick this one because I know it's going to start at 3. And then it goes up to 7. But then I know it's 2 pi. Yeah, 2 pi. So this is how the graph looks like. Okay. All right. All right. Okay. So question 6. So we're going to sketch this graph, this trig function. It's a sine graph. So fx equals to -2 sine pi x plus 3. So interesting, right? So first thing first, we need to look at the midline. Midline is y equals to 3. So draw y equals to 3, dotted line across. And then look at the, oh, interesting, there's a negative sign there. So it's a -2, so we know the amplitude is 2. Right? 2 on top and 2 below the midline. So the highest point will be at 5, and the lowest point will be at 1. But the negative sign actually flips the graph upside down. So instead of a normal graph, which it starts from 0, goes up, it comes down. So it flips it. So it goes down first and then comes up. All right? So let's find the period. The period is actually 2 pi divided by, so the thing in front of the x, it happens to be pi. So 2 pi divided by pi, the pi cancels off, it's 2. So we now know that the period is 2. So now we divide the graph into 2. Now look at the x-axis. It's in radian. So divide into 2, 2, 2, 2, 2. Okay, so, and then we're going to halve it. All right. And then we're going to mark the original point, the point where the graph starts. Right? Because it's sine, it starts there at 3. And then it goes, it goes back to the middle. And then it ends one complete cycle back at 2, right, in a 0, at y equals to 3. But it goes down, right? It goes down first. So it's going to go to -1 first, in between the first half, and then it goes all the way to 5 in between the second half. So it's going to look like this. So with this in mind, can we just repeat the cycle? Here we go, here we go, here we go, here we go. All right, so I'm going to show you how to do it on the computer. Now, since this is sine graph, I'm going to pick the one that has the dot starts from the middle. And I know it's going to start at 3, but it's going to flip, right? So it's going to flip and right here, I think. Okay. So that's how the graph is going to look like. Okay, question 7. Sketch a graph of the function fx equals to 2 cosine pi x minus 3. So first thing first, midline, y equals to -3. So draw a dotted line across -3 because it's going to start from there, right? It's the halfway point, up above, down below. And then we need to look at this number, which is 2, and that's the amplitude, right? Amplitude is 2, so the maximum it goes up, it's a -1, and the minimum goes down, it's -5. So what's the period? 2 pi divided by, what's the thing in front of the x? It's pi, actually. So 2 pi divided by pi cancels off, the period is 2. So let's mark it out, 2, 2, 2, 2. And then halve it. Now, it's interesting because the next thing we need to look at is what function is this? This is cosine, so it's going to start from the maximum, the amplitude. And in this case, the amplitude is -1, right? And then it going to go down to -5, but that one is going to be in the middle of the halfway point. And then it goes back up to -1, and that finishes the cycle, and it looks like this. So let's finish the whole thing. Okay, so, and this is the point where I take the drawing out and I show you how to do this. Now, which one would I pick? I don't pick the one with the dot starts in the midline. I'm going to pick the 2 dots with one up on the crest and one down on the bottom, right? So it's going to start at, what did we say? -3. Okay, so. All right, and it's going to go down to, okay, so I believe the midline is -3, and then it starts at -1, and then finish one whole cycle. The lowest point is -5. Okay, I believe this is it, and I can show you the. All right, cool. All right, the answer. This is the solution. Okay, I believe this is the last question. All right, so it's not the last question, so I think we have two more. But anyway, this is not easy. This one, it's a tricky question. So consider the equation fx equals to 2 cosine x minus pi over 2. Now this looks different from what we have been doing so far. So determine the following information. Give exact answers using fractions and multiples of pi as necessary. So, right, we need to look at the midline. Here the midline is 0, the amplitude is 2, so it goes as high as 2 and then as low as -2, right? And then we look at the period. Now the period is 2 pi divided by, there's nothing, no number in front of the x, so we know that it's 2 pi divided by 1. So every 2 pi, it finished the cycle. Now, so this number is something that we have not talked about, or it's not common, and this is called phase shift, right? The phase shift here is pi over 2, right? We call it the phase shift. Now, if it's negative, so x minus pi over 2, so the phase shift is to the right. Now, if it's positive, if it's a plus sign, that means the phase shift is to the left. So what does phase shift mean? So here, this is a cosine graph, right? The reason why I pick cosine graph because the graph we are looking at is cosine. So it starts from the maximum. Now, phase shift means the whole thing shifted by pi over 2. It's shifted by pi over 2. So that difference, we call it the phase shift. Okay? So that means the maximum will start at pi over 2. So let's go back to the question, right? Let's see if we can make this work. So I'm going to pick this one because it's cosine. But it's going to start at pi over 2. Now I know that the amplitude is at 2, right? The amplitude is at 2. So, and the phase shift is at pi over 2 because usually it's going to start at 0. But then it moves pi over 2. So it starts at here. And it's going to go finish the cycle at not 2 pi. It's going to finish the cycle at 5 pi over 2. Yep. So 2 above, 2 below. And so you see how it shifted? It shifted by pi over 2. Okay, I believe this is the answer. There you go, right? That's the correct answer. Right, so this is question number, I believe it's question number 9. All right, question number 9. So which of the graph, you just have to pick which one is y equals to 2 tangent, tangent of x plus pi over -4. There's a phase shift there of pi over -4. So there are a few ways to do this. One, you do it by concepts, right? You do it by parts, and then you try to figure out, okay, what the graph looks like. Or you put it in the Desmos graphing, and then you just identify the graph that way. But you got to make sure that in Desmos, when you graph this, your x-axis has to be in radians, not in degrees, because it will look strange. So if you look at this, we know that the original tangent graph looks something like this, right? You have something that looks in the middle, and there are two vertical asymptotes, one to the left and one to the right. And then you keep repeating that. So there's one to the right and there's one to the left. So it looks like this throughout. Now that's for tangent, original regular tangent graph, okay? Now that thing that we see, a phase shift of pi over -4, with the pi over -4, we know that the phase shift is pi over -4, but is it to the left or to the right? It's a phase shift to the right. So now with the blue line, blue curve, do you see that the one curve in the middle, the graph, has kind of shifted pi over 4 to the right? So if you look at the 4 graphs that we have, it looks like the one, this one, okay, looks like the answer that we need. Yep. All right. Okay. Okay, so last question, question 10. Consider the graph y equals to 7 tangent 9x, right? So give the equations of the two vertical asymptotes. Now we talked about the tangent graph in the previous question, and we said that there are two vertical asymptotes, right? One to the left and one to the right. And then it keeps repeating like that. So we're supposed to, there's a way to calculate, right? Calculate the vertical asymptotes nearest to the y-axis. So they're looking for the two closest vertical asymptotes in the middle. So separated by commas, give exact answers as fractions or multiples of pi as necessary. So first thing first, right? So we write out the equation, y equals to a tangent b parenthesis x plus c close bracket plus d. Now a is your amplitude. B is what we need to do our period. And then C is your phase shift. And then plus D, which is your midline. So the formula for this is actually pretty interesting. The two vertical asymptotes goes as this: pi over 2b. And negative pi over 2b. So one positive, one negative. So what is b in this case? B is 9, right? It's the number next to, it's the coefficient of x. So it's 9. So in this case will be pi over 2 times 9 is pi over 18. And then the other one is negative pi over 18. So that's how we put the solution. Okay? So if, yeah, see, negative pi over 18 and positive pi over 18. That's how we put down the solution. And you can look at the solutions here if you need to have a better understanding. So thank you.